Welcome to NAROJ Masters Academy 10th class physics problems on based on chemical equations. Look at the first problem. Carbon is combusted with oxygen O2 and formed carbon dioxide. Calculate how much carbon is required to get 264 grams of carbon dioxide. So when carbon is combusted with oxygen, it gives rise carbon dioxide. So the atomic mass of carbon is not given in the question. So we have to remember this one. We should know the values of carbon and oxygen, then their atomic masses. So if you know the atomic mass of carbon, then right here, atomic mass of carbon, atomic number is 6, and the atomic mass of carbon is 12 grams. And the atomic number of oxygen is 8, and the mass is 16. 16 into 2 grams, 2 times. And it gives rise 12 plus 16 into 2. So 12 grams plus 32 grams gives rise 44 grams of carbon dioxide. So from this question we can say that the 12 grams of carbon dioxide is converted into 44 grams of 12 grams of carbon is converted into 44 grams of carbon dioxide. So here he asked in the question is oxygen required. Calculate the amount of carbon required to get 264 grams of carbon dioxide. 12 grams of graphite gives 44 grams of carbon dioxide. Then how much amount of carbon gives 264 grams of carbon dioxide? So do the cross multiplication here. 12 into 264 divided by 44 is equal to x. So how many times of this one? 44, 24, 2 times, 22, 2 times, 4, 11 times, and then this is 4, 4, 4, 5, 4, 6 times. How many times it goes? 2 into, yeah, very good answer. How much? 72 grams. Huh? Okay. So x is equal to 72 grams. So 72 grams of carbon is required here to get 264 grams of carbon dioxide. Look at the next problem. How many grams of oxygen is required for the combustion of 480 grams of magnesium? Find the mass of magnesium oxide formed in this reaction. So basically to convert the magnesium into magnesium oxide, first make the reaction between magnesium and oxygen. It gives rise MgO, magnesium oxide. It is not balanced now. So best balance the chemical equations. If you make 2 plus 2 here, then 2 Mg plus O2 gives rise 2 MgO. So what is the mass of atomic magnesium here? 24 units, and oxygen is 16 units. So 2 into 24 plus oxygen is 16. 16 into 2 gives rise 2 into 24 plus 16. So this is 48 grams of Mg plus 16 to the 32 grams of oxygen gives rise 24 plus 16 is 40, 42 times 80 grams. So what he asked in the question, how many grams of oxygen required for the combustion of 480 grams of Mg? Basically for 48 grams of Mg, 32 grams of oxygen is required. So for 480 grams of Mg, how much amount of oxygen is required. Then do the cross multiplication. X is equal to 480 into 32 by 48. So 48 once, 48 10 times. 10 into 32. So X is equal to 10 into 32, that equal to 320 grams. So 320 grams of oxygen is required. But what is the next question here? Find the mass of MgO formed. So magnesium oxide formed in this reaction. So 480 grams plus oxygen is 320 grams. How much it is total? 480 plus 320 is 700, 800 grams. So in this reaction, 800 grams of magnesium oxide is formed. And the amount of oxygen required is 320 grams. Look at the next problem. Calculate the mass, volume and number of molecules of hydrogen gas liberated when 230 grams of sodium reacts with excess water. So first make a reaction between sodium and water here. So sodium indicates with Na plus water is H2O, gives rise NaOH plus H2 gas. Na atomic mass is 23 units and oxygen is 16 units and hydrogen is 1 unit. So Na is 23. First balance the chemical equation here first. So it is not balanced. If you place 2 here, then 4 hydrogens plus 4, 4 hydrogens, 2 oxygens and 2 Nas. Now it is balanced chemical equation. So 2 times of Na, 2 into 23 units plus 2 into 1 hydrogen. So atomic mass of hydrogen is also 1. 1 into 2 plus oxygen is 16 gives rise 2 into Na is 23 plus 16 plus 1 plus 1 into 2. So here 46 plus 2 plus 16, 18, 18 2 is a 36. 36 grams. And this is 23 plus 1, 24 plus 16. 40, 40 into 2, 80 grams. Plus 2 grams. What he asked in the question, calculate the mass, volume and number of molecules of hydrogen gas liberated when 230 grams of sodium reacts with excess of water. So basically from this 46 grams of sodium gives 2 grams of hydrogen. Then 230 grams of sodium gives how much amount of oxygen, hydrogen gas. Do the cross multiplication. X is equal to 230 into 2 by 46. So 23 once, 23 2 times, 0, 10, 2 once, 2 times, 2 5 times. Then it is X is equal to 5 into 2, that equal to 10 grams. Yeah, very good answer, Amma. 10 grams of hydrogen. So X is equal to 10 grams. So this is the mass of hydrogen gas liberates. Then what is the next step? To find the volume. To find the volume, so 1 molar mass is equal to, or 1 mole is equal to 22.4 liters. So here 1 mole of gas is equal to, of hydrogen is 2 grams. 2 grams of hydrogen is equal to, hydrogen is 1 mole, that equal to 22.4 liters. Then 10 grams of hydrogen is how many liters? So 2 grams, basically 22.4 means 10 grams. Do the cross multiplication again. X is equal to 10 into 22.4 by 2. So this is 224 by 2. That equal to 112 liters. So the volume is 112 liters. What is the next step? Number of molecules present in number of molecules of hydrogen gas liberated. So to find the number of molecules, Avogadro's number required here. So one Avogadro's number is equal to Avogadro's number is equal to 6.023 into 10 power 23 molecules. This is also equal to 1 mole. So 1 mole of hydrogen gas is how much? 2 grams of hydrogen gas is equal to 1 mole. So 2 grams contains 6.023 into 10 power 23 molecules. Then 10 grams contains how much? Again cross multiplication. X into 2, X is equal to 6.023 into 10 power 23 into this 10 by 2. So 2 ones, 2 5 times. 6 5s are 30. So X is equal to how much? 30.01 into 10 power 23 molecules. So these are the answers for this question. X is equal to 10 grams and here 112 liters and 30.01 into 10 power 23 molecules. Or we can also write like this. X is equal to 3 into 10 power 24. Instead of writing 30 here, 3 into 10 power 24 molecules also. Look at the next problem. Calculate the amount of aluminium required to get the 1120 kg of iron from iron oxide. So basically first write the equation between the aluminium and iron oxide. So this is aluminium. Aluminium reacts with iron oxide. Iron oxide chemical formula is Fe2O3. Gives rise aluminium oxide Al2O3 plus iron. So this is unbalanced equation. So balance this one first. Here two aluminiums are there. To place 2 here, 2 Fe, 2 Fe. Now it is balanced. Now masses of each element is given here clearly. So then write the masses here. 2 into 56, 2 into 27 plus iron is 56 here, 56 2 times plus oxygen is 16, 16 3 times. Gives rise, aluminium is 27, 27 into 2 plus oxygen is 16, 16 into 3 plus 2 into iron is 56. So here 27 into 2 is 54 grams plus 56 into 2 is 112, 112 plus 48. 160. 27 into 2 is 56, 54 plus 48. How much it is? 102. 102 grams plus 56 into 2 is 112 grams. So what he asked in the question, calculate the amount of aluminium required to get 1120 kg of iron from iron oxide. Basically 54 grams of aluminium is required to get 112 grams of iron. Then to get 1120 grams, 1120 kg, not grams here. 1120 kg of iron. So how much amount of aluminum is required? Do the cross multiplication here and convert this kg into in terms of grams. So 54 x is equal to 54 into 1120 kg here. 1120 into 1000 grams by 11 112. So 112 once, 112 10 times. So 540. So this is equal to 540 into 1000 grams. That equal to 540 kg. X is equal to 540 kg. So 540 kg of aluminium is required to get 1120 kg of iron from iron oxide. Look at the next problem. Calculate the mass volume of oxygen required at STP to convert 2.4 kg of graphite into carbon dioxide. So again the same question like as first one, but here the amount of oxygen required is the question mark. Calculate the mass. Mass means mass question mark and volume also question mark here. Of oxygen required at STP to convert 2.4 kg of graphite. Graphite means carbon. So when carbon reacts with oxygen, it gives rise carbon dioxide. What is the atomic mass of carbon here? 12 grams. Oxygen is 16. 16 into 2 gives rise 12 plus 16 into 2 grams. So 12 grams plus 32 grams gives rise 44 grams of carbon dioxide. From this, 32 grams of oxygen is required to get 44 grams of carbon dioxide. Okay. Or to convert 12 grams of graphite into carbon dioxide, how much amount of oxygen is required? For 12 grams of graphite, 32 grams of oxygen is required. Then for 2.4 kg of graphite, how much amount of oxygen is required? So then cross multiplication, x is equal to 32 into 2.4, 32 into 2.4. It is in terms of kg, then write in terms of grams, 1000 by 12. That equal to 32 into 2.4 into 1000 is 2400 by 12. 12 once, 12 200 times. That equal to 32 into 200, 6400 grams. That equal to 6.4 kg. Very good answer, Amma. 6.4 kg. And what is the next question here? Find the volume also. Volume means 1 mole is equal to 22.4 liters. 1 mole of oxygen means 32 grams of oxygen here. So 32 grams of oxygen is equal to 22.4 liters. Then we have here 6.4 kg of oxygen. So 6.4 kg is equal to how much? Again cross multiplication. So x is equal to 22.4 into 6.4 means 6400 grams by 32 grams. 32 once, 32 200 times. Then x is equal to 22.4 into 2 is 44.8 into 100. That equal to 4480 liters. What is the volume of oxygen here? 4480 liters of volume. Very good answer. Look at the next question. 1 mole of propane on combustion at STP gives a kilo of joules of heat energy. Calculate the heat liberated when 2.4 liters of propane on combustion at STP. So here clearly given 1 mole of propane is given to combustion at STP. So combustion process means it liberates carbon dioxide gas. First write the reaction here. C3H8 in the presence of oxygen gives rise carbon dioxide CO2 plus water molecules H2O plus heat energy. How much amount of heat energy is liberated here? 8 kilojoules of heat energy is liberated in this reaction. So it is unbalanced now. So balance the equation first. So if you place 4 here, 4 hydrogens, 8 hydrogens, carbon. So 3 carbons and place 3 here. 3 carbons. Then oxygens 6 here and then place 3 here, 5 here. 10 plus 6 plus 4, 10. Now it is balanced. So 1 mole of propane means this total amount is known as 1 mole. So if you take it as 1 mole, 1 mole, this is basically we will consider as O2 is equal to 1 mole. So how many O2s are here? 5 O2s. So this is 5 moles of oxygen gives rise. So this is 3 mole of carbon dioxide. So 1 carbon dioxide. So here 3 moles of carbon dioxide plus this is H2. H2O is 1 mole and 4 moles. 4 moles of water plus heat energy. How much amount of heat energy liberates here for 1 mole of propane? A kilojoules. So this is A kilojoules of heat energy. Okay. So we know that 1 mole is equal to 22.4 liters. We have here 2.4 liters only. So 1 mole is equal to 22.4 liters. 1 mole liberates a kilojoule. Then here 1 mole is equal to 22.4 liters. Means 2.4 liters is equal to how much? Do the cross multiplication. X is equal to 1 into 22.4 liters by 22.4 liters. This is approximately 1 by 0.22.1 means 1.0 1 by 0.93 something. You'll get that is equal to 0.171. Okay. This is x is equal to 0.171. So here 2.4 liters liberates 0.171 liters of kilojoules, or liters we can say here kilojoules of heat energy liberates. Basically, if we have 22.4 liters means we will get a kilojoules. Here we have only 2.4 liters of kilojoule, 2.4 liters of propane here. That's why you got 0.171 kilojoules. Look at the next problem. 2 moles of zinc reacts with cupric chloride, that is CuCl2 solution containing 6.023 to 10 power 22 formula units of cupric chloride. Calculate the moles of copper obtained. So basically write the reaction between cupric chloride and zinc first. Zinc reacts with cupric chloride, that is CuCl2 gives rise ZnCl2 plus copper. So we need to calculate the how much amount of copper is obtained from this reaction. So first balance the chemical equation here. Zn, Cl2, Cl2, copper, copper. Yeah, it is balanced already. So the mass is not given here. So simply consider as this is 1 mole. 1 mole of zinc is required to convert 1 mole of cupric chloride. So this is also taken as 1 mole. 1 mole of Zn is required to convert 1 mole of cupric chloride CuCl2 to convert into 1 mole of zinc chloride plus to get 1 mole of copper. So here 1 mole of zinc required to get 1 mole of copper. So what he asked in the question, 2 moles of zinc reacts with the cupric chloride. It means if you take 2 moles react with the cupric chloride. So we need 2 moles of cupric chloride. Then we will get 2 moles of zinc chloride plus 2 moles of copper. So actually we have the solution here 6.023 into 10 power 22 only, not 23. If we have the 23 means we can say 1 mole. Here instead of 1 mole we have only 0.1 mole. So here we have only 0.1 mole. Instead of 2 moles, 0.1 mole we have. Then how much amount of copper we will get here? 0.1 mole only we will get. So just listen here clearly. So 1 mole is equal to 6.023 into 10 power 23 molecules or formula units. So we have only 6.023 into 10 power 22 means what? 0.1 mole. So from this reaction, 1 mole of zinc gives 1 mole of copper or 1 mole of cupric chloride gives 1 mole of copper. And then 0.1 mole of cupric chloride gives how much amount of copper? 0.1 moles only. So the answer for this is 0.1 moles of or 0.1 mole of copper is obtained from this reaction. Okay, na? Yeah, with this, all problems based on the second chapter are over. If you want more problems for your practice, send a message to my mail ID or comment on the comment box. Then I will share you the questions. Thank you.